Okay, so after our discussion about the general structure of lactose, in that video I am going to discuss about the negative regulation. Okay, so the condition in which lactose is not present in the environment. So before going to discuss about our regulation discussion, I want to clear that I will use O for operator, T for terminator, and P for promoter. So positive regulation when lactose present in the environment, that I will going to discuss in our next video, and negative regulation when lactose is absent in the environment. Okay, so here the important thing that I first want to clear you, that RNA polymerase is the main funda of transcription. So RNA polymerase will recognizes the promoter with the help of sigma factor and start the transcription. Okay, now let's start our discussion what is going on in case of negative regulation. So this is the gene of lactose operon. This is the regulatory part, and this green marked portion is the structural part. Okay, so what is the mechanism? First of all, RNA polymerase will find the promoter of regulatory gene. Okay, once it find, it start the synthesis of LAC-I, but don't forget that P is a weak promoter. It will start LAC-I expression in a very low concentration and in a very slow rate. Okay, concomitantly the RNA polymerase will also find the promoter of the structural part. Okay, but there is a problem I am going to discuss. So LAC-I's expression will give us the repressor protein, which is by default a active protein. Okay, so as it is a active protein, it has affinity to bind with the operator of the structural gene. Okay, so once they are synthesized, they will directly go to the operator of the structural part to bind. Okay, so as a result, RNA polymerase that incorporated with the promoter of the structural part do not start the transcription because there is a operator as a obstacle in their way. Okay, so that is how the repression is going on. Okay, so this is nothing but the repressor protein synthesized by LAC-I, which is by default a active protein, and it will after synthesis just immediately go to the operator site of the structural gene. Okay, and prevent RNA polymerase to transcribe LAC-Z, LAC-Y and LAC-A, and as a result operon cannot work. So that is the negative regulation of lac operon when lactose is absent in the environment. But whenever lactose is available in the environment, this lactose will somehow convert it into a product that I am going to discuss. This product will inactivate that active repressor protein, and as a result it converts into inactive repressor protein, and this inactive repressor protein no longer have the ability to bind with operator, and as a result RNA polymerase finds its way to start the transcription, and it eventually starts. So that is how negative regulation going on. Okay, so in the next video I am going to discuss about how positive regulation, how lactose will inactive the repressor protein. Okay, so till then keep watching, and thank you for listening to this class.